Hi then guys, right, so I've put 3 NMRs and I've just done 2 more, so that makes 4, 5. I'm on the 6th video of NMR and there's still a fair few to come on it, but if you do them in sequence and when I upload them you should be able to see what's what on it and go through that sequence. I'm trying to make the videos a little bit shorter because it takes, the last one I uploaded, it took me 3 days to get it uploaded. It kept crashing, it took hours and hours and hours, and then it would upload and then suddenly it would crash and then I had to start again, and it took hours and hours again, even overnight. It wasn't having it. So if I can make them a little bit shorter, I thought it might help a little bit in the uploading of them. We'll have to see. So what I'm going to do now, this is still on low resolution NMR, and I'm going to do some show how aromatic rings fit into low resolution NMR. So these last 2 videos, I think they're on take us up to about number 7. These last 2 videos will just finish off low resolution NMR, and the next time I see you on, I'll be talking about splitting, spin coupling, and introducing that into the equation as well. It gives you more information, helps you more. So we'll stick with the low res. Once the low resolution has been done, 2 more examples of that, we'll move on to the high res stuff and the serious stuff, okay? Yeah, all right. So without further ado, let's crack on with this. Okay. So let's have a look at this one. I'm going to put an aromatic ring in. Okay. These come up quite a lot in the spec. So CH2. Again, it's still an ester configuration. There. Alright, table underneath. We'll have another column on this, as I keep saying, when we look at spin coupling. So we're talking environment, chemical shift, integration. I'll do us for now. Always do this, although we're going in the reverse direction. Okay, this. Now I need to alter my scale on these because if you look at your table of chemical shifts, you'll find aromatic stuff goes on between about 6 and 8. So I need to go up to about 8. Relative intensity. Okay, 8, 4, 0, 6, 2, 1. 3, 5. Again, as with all these, if you're on it, you have a go first. You press pause, make sure you do, and you fill this in before Tim, as always, babies you on how to do it. Alright, so you do this yourself first. Use a bit of brain. Never mind me, use your brain. Okay, right, so let's have a quick look at these environments. H, C, single bond, O. 3 to 4. There's 3 in that environment. Okay. Now I've got to watch this quite carefully. But before I'm going to do these 2 in the middle, okay, I'm going to look at these benzene ring ones. Now if you look at your chemical shift, protons attached to a benzene ring are between 6 and 8. They certainly are. So in other words, what we have here is benzene ring. H is attached, protons attached between 6 to 8. And there are in that environment, and this is quite important, classic monosubstituted benzene ring integration 1, 2, 3, 4, 5 monosubstituted. Before, if it was disubstituted. Okay. Alright, and then we look at these 2. Now, we've got sort of competing here. If you look at your table, I'll show you this in a minute. There's protons that are attached to a carbon, which are attached to a benzene ring. So that's an influence, a chemical shift on these two here. But they're also attached to a carbon attached to C double bond O. So that, if you look at your table, I'll show you this, so whether you can see it. I'm looking at H is joined to a C, joined to a benzene ring. That's an influence for those two. But I'm also looking at H is joined to a C, attached to a C double bond O. Both have the same region. And that can cause issues later on. But we'll look at that. So in other words, 2 to 3 for those, but they're also under the influence of this C double bond O, which just happens to have the same chemical shift. Okay, either way, so those two really I should sort of group together because they're the same protons, those two. Either way, there's 2 in that environment, no problem. Okay, so let's draw the spectrum of that quickly. Two to 3, 3 to 4. So, going along here, 2 to 3, 3 to 4. Again, I'm not really drawing these peaks in any particular size. And then 6 to 8 up here, classic benzene ring territory. Okay, right there. Okay, let's put an integration on. Alright, and let's just suss this out. So 2 to 3, those two. So we'll label those number 1. Label that number 1. Number 1, integration of 2. Same deal. Okay. Next, 3 to 4, classic stuff, HC single bond O, HC single bond O, 3 to 4, 3 in there, certainly are. So we'll label those 2. Last but not least, the benzene ring protons, there's H's on here. Be clear, 1, 2, 3, 5 H's on there. Hence an integration of 5. Okay. And in the chemical shift region, if you look at your data sheet, that there, 6 to 8. So, in other words, 1, 2, those protons in the benzene ring we'll label as 3, put a 3 there and put a circle around it. Okay, so, not bad, not bad. I think that's okay. 2 to 3. Let me just check it. Yeah, looks good. Okay. Looks fine. One more. These are getting very close to A-level questions. I'm deliberately building up the low res as much as I can. Okay, because the splitting is an embellishment. Makes it more complicated. But again, it doesn't, it just splits the existing low res peaks, okay? But anyway, deal with that in a minute. Now let's have a look at this beast, which is very similar to an A-level one, which I think was a bit of a tricky A-level one, but anyway, just to show you, got a benzene ring sat there. They like this, they like to put benzene rings in. And this one is substituted at both ends. So you've got CH2 on there, and then CH3. Okay. On this side, another CH2. And then C, an aldehyde group. So I'll get my red straight away. How many different environments on that? Environment 1, environment 2, environment 3. Environment 4. No problem. Okay, our table. There you go. Env shift, int. Right. Let's take these nice and easy. Start over here. Number 1. Do them in this sequence. 1. I've missed an environment 84. 5. The protons on the benzene ring. There's 5 different environments. 1, 2, 3, 4, 5. See, easy to forget. There they are, look. 5 protons there, hidden away. Okay. So, let's start on this one. HCr, bang on. Right, hydrocarbon chain. Chemical shift, 0.5 to 2. Integration, there's 3. Job done. These 2 here are, watch out, these. Look on your data sheet and you'll find them. H joined to a carbon, joined to a benzene ring. 2 to 3, no doubt about it. And there's 2 in that environment. Okay. Look at number 3. Number 3 is a bit weird because it's exactly the same. Monosubstitute, we've got 2 things going on, 2 influences on those. And that means actually, well, we'll discuss that when we look at an A-level question. So we've got that, but they're not identical to those because they're joined to that business there rather than a methyl group over there. But they're still going to, so 2 to 3 for that. But we've got another influence on these, okay? Plus, so I'm still looking at just these 3 here, plus they have the influence of C, H, C, C, double bond O on there. So 2, there should be a plus there. 2 different influences. That's 2 to 3 as well, chemical shift. So H, C, C, double bond O. Either way, there's 2 in that environment. Okay. Number 4, out on its own. What is this? Carbon, a proton joined to a carbon which is directly bonded to a double bond O. A sort of an aldehyde type scenario, I suppose. Stuck out on its own over there, they normally are. Anyway, that's 9 to 10. 9 to 10. I'll just be clear. 9 to 10. Can you see that? 9 to 10. Okay, cool. How many's in it? 1. And then your benzene ring 1s, which are in the region of 6 to 8. H is directly joined. There's 4 in that environment. 6 to 8. And there's 4 in there. You should be able to do that yourself before I do it. So be a bit disciplined. Use a bit of self-discipline. Self-discipline's a good thing. Relative intensity. Chemical shift. 10. 0. Because that will encompass everything. 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 9. Okay. Right then. Hopefully I won't cock this up. Go to red. Easy bit first. Lines along here. Peak there. That's going to be peak number 1. I do the integration trace in a minute. Now 2 to 3, I've got them going on at 2 to 3, and I've got these at 2 to 3, but not quite the same, because the environment of those two and those two are not identical, because one's joined to one of them, one's joined to one of them, so they're subtly different. But 2 to 3 is a busy area in this particular case. So I'm going to do a couple there, 1, 2, in the 2 to 3 area. Okay, and those are 2. I don't know which one's on the left, which one's on the right. 2 and 3. Okay, very similar but not identical. Then we can move away from that to 6 to 8. Okay, which is going to be number 5, benzene ring. Okay, and then finally the aldehyde proton stuck out here on its own, which is number 4. You've got to think about that when you're doing it, right? Integration trace. This is, you've got to watch this. You should be doing this yourself quite a lot. Okay. So on the integration trace, 9 to 10. 9 to 10. That there. That's the chemical shift for it, 9 to 10. There's only one in that environment. Do you agree? Of course you do. Right? You can't say nothing, can you? I can't hear you. Alright? Anyway, 6 to 8, 1, 2, 3, 4. Biggie this, 6 to 8. Those are aromatic protons, so that actually has an integration 4. There's 4 protons in that environment. Okay? Then we're talking, I've done that. Then we've got these H's joined to a C, H is joined to a C, which is joined to a benzene ring. Now, I don't know which way round and they're too close together, but basically 2 and 2. 2 in one environment, 2 in the other. Whichever way they are, 2 to 3, it doesn't really matter. Very close, maybe even overlaid, and there's a question whether I have to take that into consideration, because if one was slap bang on top of the other, you wouldn't see it. Okay, so we have to watch that a little bit. Anyway, I'm going to see the question, that'll make sense. And finally, an easy one. Those 3 there in a hydrocarbon chain, 0.5 to 2, that chemical shift right down here, integration of 3. Can we just check I got that right? 3, 2, 2, 4, 1. There you go. So that's gives you an idea of sort of the different environments you might get, and puts an aromatic ring into the equation. Very close to an A2 card, A2 question, but without the splitting, the spin coupling. Okay, which, because I can tell you now that these two are going to interfere. They're going to split. These peaks are going to be split into, you're still going to get essentially 5 different environments, 5 different peaks, but each peak may or may not be split. We'll look at that later. If they're adjacent, though, so those 2 are going to be split by that, and that's going to be split by those 2, and those 2 are going to be split by that, and that's going to be split by those 2. Okay, and we'll discuss that in the next video when I talk about the M+1 rule and splitting patterns. And then that's it, essentially. You've got everything you need then to be able to deduce spectra and all that sort of thing. Okay, thank you. Right, catch you later, guys. Can never think of anything to say when I'm doing these, which is a bit weird, but it's a nice sunny day anyway, although it's a blooming cold wind, I can tell you now. Yeah, and I'll move on to the splitting bit in the next video, which I can't remember, but might be number 8. I'm not entirely sure, but do them in sequence, otherwise you'll probably get lost with this, because it takes a bit of you getting your head round, really. Okay, but I think it's worth doing. Okay, it completes the specification, and I think it's worth doing. Okay, I'll see you soon.